In this video, we will discuss how to do multiple transformations on a function. Now, there are 4 transformations that we talked about, and this is the correct order that you should be doing them if you have multiple transformations on a function. So the first thing you should be doing is any horizontal translation, okay, any shift from left to right. That should be done first. I've listed some little terms here, little notes to help you think about what you should be looking for in the function. All right, the second thing you should do is any horizontal dilation, whether that's a shrink or a stretch, and any horizontal reflections. Those should be completed at this time. Then after you've done those, the third thing you should do is look for any vertical dilations, whether it's a stretch or a shrink, or any vertical reflections at that point. And then the last thing you should do is do your vertical translation up or down. So I usually tell my students, write the 4 in order, do them in the same order every single time, and then complete those. And if you need to, graph each one as you do them, which I have been known to do, especially when I do these in a classroom setting. It tracks a lot better. So I'm going to do them each individually with you as well. And we're going to go through these 4 steps. And I'm going to use a different color. So it's going to get very crowded on your graph very quickly. So I apologize in advance for that. But I do think it really helps to see what's going on. So here's our first one. Okay, so we are going to go through step by step and talk about the different ones that we have to do. All right, so first off, okay, step number 1, you should be doing any of your horizontal shifting. So that's the first thing I'm going to look for. So number 1, do I have any horizontal shifting on this graph? And the answer is yes, I do, right? See right here, I have some horizontal shifting. So that means I'm going to shift, again, +1, you think it'd be right, but it's not, it's left 1. So that's the first thing I'm going to do to my graph is I'm going to shift it left 1. So every point I'm going to shift to the left 1 point. And then redraw my graph. So there's my graph with everything drawn, 1 shift to the left. Okay, so that's my first. Then the second thing I'm going to look for is any horizontal dilations or reflections. So is there anything multiplied by x? There is not. Is there any negatives in front of the x? There is not. Okay, so there is no horizontal. So I'm going to write that down even though I'm not doing anything. I'm still going to write it down because I want to make sure that I have that noted. So there are no horizontal dilations. So no horizontal dilation or reflection. Okay, so that's good. Okay, step number 2, we're done. Okay, I should put a 2 in front of that because that's step number 2. Okay, step number 2. Step number 3. All right, step number 3, you're going to look for any vertical dilations or reflections. So notice right here, I've got that 2. So it's not negative, so that means there's no reflection. So I'm going to write that down. There's no vertical reflection, but there is a dilation. So no vertical reflection. Okay, but we are going to have that vertical stretch, right? So there's going to be a vertical stretch by a factor of 2. So we are going to take each point here and we're going to make it twice as far away from the x-axis. But again, the x-intercepts are not going to change. So this x-intercept is going to stay, this x-intercept is going to stay, that's going to stay. But this point, which is 3 away from the axis, is now going to be 6 away. So that point is now going to be twice as tall, right? This point, which was 3 away, is now going to be 6 away. So it's going to be twice as tall. So I stretched it twice as far away from the x-axis. So there's my vertical stretch. All right, and then the last thing you need to look for, step number 4, is do you have any vertical translations? So number 4, and I do, right? Notice right here. That's a vertical translation down 3. So the last thing I'm going to do is take this whole graph and I'm going to move it down 3, and that's going to be my final answer. So what I draw in blue, you know what? I should use a different color than blue since my original graph was in blue. Let me use purple. So number 4 is going to be down 3. There we go. That makes it stand out a little bit. So we're going to take this graph and each point we're going to move down 3 units from where it is right now. So every point that's on the x-axis is now going to be moved down 3, so they're all going to be 3 units below where they were before. This peak would be moved down 1, 2, 3. Notice I'm going to go off the graph. I apologize for that. and then this point is going to go down 3. 1, 2, 3. So it's still going to be tall and skinny, but I have moved it off the axis. So that one in purple, that is my final graph. That is my g of x. So you may want to do these in color to kind of help you, or maybe do them on separate graphs. I know a lot of people like to do that as well, but I like to keep it all on one graph so I can kind of see it moving, even though it looks like a hot mess right now. But know that that g of x, that one in purple, that is my final answer. That has done all the transformations that I need to do. So if you keep that pattern where you keep going through the 4 steps, you shouldn't have any problems, but go slow. If you need to make all the charts that go with it, please feel free to do that. Takes up a lot of space, but it gets the job done. So again, whatever you need to do to be successful in your transformations. I'm a visual learner, so I just learn from looking it on the graph. If you're not, please feel free to do those charts. You should get the same answer that I got as well. So. All right, so here's another one. Again, same graph we've been using the whole time. All right, here is the function I want you to find g of x. Okay, so, and they want your final answer to be in red. Okay, so let's start in purple this time. So step number 1, again, step number 1, you are looking for any horizontal shifting. And notice inside, I do have a horizontal shift of left 1. So the first thing I'm going to do this whole graph is I'm going to shift it left 1. So every point is just going to get moved 1 to the left. That point's going to go over here. This point's going to come over here. This point's going to come over here. So it's still going to be constant, going to have that parabola looking shape, and then we're going to have the straight line. Whoops, let me try to make that a little bit straighter. Again, please don't judge me for my inability to draw a straight line on my computer screen. Okay, so there's the graph. Okay, so there's my horizontal shift. Okay, next step, number 2, is that's when you're going to look for anything multiplied in front of the x. So there's no stretch or shrink here horizontally. There's no reflection because I don't have a negative in front of the x. So, okay, so there's no horizontal dilation. I should learn how to spell. You know, you think at this age I'd figure it out, but that's okay. Horizontal. So no horizontal dilation or reflection in this case. Okay, then we move to number 3, which, let's see, I don't want to use blue. I don't want to use red because that's going to be my final answer. So let's use orange. Okay, so number 3. Right, number 3, you want to check for any vertical dilation or reflection. So notice we do have a 1/2. So it's not negative, so there's no reflection because there's no reflection out there in front of that 1/2. No vertical, I should say. Let me specify that. No vertical reflection, but I do have that 1/2. So that means I am shrinking it vertically. So I'm going to shrink vertically by 1/2. So I'm going to make it half as tall as it is. So anything that's on the x-axis is going to stay on the x-axis. All right, so those points are all the same. But all the rest of the points are going to be half as far away from the x-axis as they was before. So like this point is 4 away, it's now going to be 2 away. So my dip is going to be a little bit smaller. And then this point that's 5 away is now going to be 2.5 away. So 1, 2.5 would be right there. This point that is 4 away would now be 2 away. This point will stay. So notice it's also going to change the slope on that line. All right, so there is the graph in orange. All right, and then I'm going to end this in red because I'm on my last thing. So last thing I need to do is any up or down. So notice I do have down 2. I have that vertical translation, down 2 units. So I'm going to take each of the points that are here and move the whole thing down 2. So this horizontal line is now going to get moved down 2. And then this point that was at 2 is now going to get moved down to 4. And this point that was at 0 is now going to get moved down to -2. And this point at 2.5 is now going to get moved to 1/2. This point that's 2 would get moved to 0. And this point would get moved down to -2. So there's going to be your parabola-ish looking thing. And then there's your line that should be, again, notice they're parallel to the orange one. So that in red is my final answer. And yes, I know it looks like a hot mess. But hopefully you've been able to keep along and catch the drift of what I'm getting at here. All right, so these, when you have multiple ones, they can be a little bit ridiculous. So just notice that we could have problems here, and that happens. So don't take it personally. Just know that you will need to take some time and work through these. All right, next one up says we have multiple transformations here. This one has a negative in front of the x. So let me give you some heads up about when you see negatives in front of x. So if that happens, what you really should redo is you should rewrite this original formula. So right now, this is what we have. G of x equals the absolute value of negative x minus 2. In order for this to work correctly, and for me, it's more like justifying what it looks like as a function versus what it looks like on the graph. I need those to be consistent. So this is how I would rewrite it to get everything to work the way I need to. You need to factor out that negative. So that if I factor out that negative, this is what I would have. So this plus 2 is going to be your horizontal shift. So that x plus 2 is going to be your horizontal shift of 2 to the left, right? Does the opposite because it's a plus, so we want to go. And this is a reflection. So that is the reflection over, and again, make sure you always get these reflections right, because the number one mistake I see is people get them backwards, and I get them backwards sometimes too. So just make sure that you're paying attention. Okay, that's a reflection over the y-axis. If the negative was outside the absolute values, then it would be a reflection over the x-axis. So if it's inside, it's y-axis. All right, so this one only has those two. So normally this, if I were to draw my original parent function, right, I'm just going to do that in black. Actually, you know what? I should do it in blue because I just did g of x in black, so let's keep it consistent. All right, so our f of x, our original parent is just the absolute value of x, which would be, right, our nice V shape with a slope of 1 and negative 1 on our two sides. Okay, so that's our normal f of x. Now, we're going to take this f of x, we are going to shift it horizontally 2 to the left, and then we are going to reflect it over the x-axis. You can do that at the same time if you want to. I'm going to do it in 2 steps. So I'm going to do this step first in orange, and then I will finish off the graph in green. So I will finish it off with that step. So let's focus on the shift first. So 2 to the left would put it over here, and then these would still have a slope of 1. So over 1, up 1, over 1, up 1. I just like to put some dots in there. It helps me guide when I'm doing my drawing, because I'm not very good at drawing. I don't know if you've noticed that, but I'm really not that good. Okay, so there's my shift. And then the last thing I need to do for this guy is to flip him. Oh wait, I've got extra thing. I forgot to see that plus 1 over there. Okay, so I've got to, hold on, let me back up. I need to add a little bit. I forgot a plus 1. I forgot a plus 1. There's a third thing. So I'm going to do my final one in black. That plus 1 that I kind of forgot about over here is going to be my vertical up 1. So I've got 3. Sorry, I didn't even see that. Guess that just goes to show you should really pay attention to what you're doing, right? All right, don't leave out any details. All right, so let's do the reflection next. So I'm going to reflect this one in orange over the x-axis. So it's still going to have a slope of 1 on either side. All right, so it's still going to look like that. Still gonna, I'm going to draw some points because I'm having a hard time. Here we go. Okay, so there is the orange one has been reflected over the x-axis. And then my final one, which will be in black. Again, that's my g of x. It's my final function with all 3 of the transformations is to take that one in green and move it up 1. So every point gets moved up 1. And notice those lines should be parallel, right, to the sides of before. So this in black, that's my final answer. That's my g of x. So notice how this can be a little confusing and the steps can be a little challenging. So again, don't be afraid to draw each step out or to put the charts for each step. Whatever it is you need to do, you do it. Again, I'm a visual person, so I like the graphs, but if you need to use the charts, please feel free to use the charts. All right, last one. Oh, but I do want to reiterate again that point where if you see this inside, make sure you factor it first and then do your transformations. So I would put a big star in my notes right there, big red star, like make sure that you do that factoring. And then once you have the factoring done inside the function, then do the transformations. It'll make your life a lot easier. It took me a long time to learn that lesson. And I'm only sharing that because I know what's going to happen to you when you take pre-calc and you start doing transformations on trigonometric functions is you're going to be doing all of these at once, and factoring it out like that is really going to help you do these transformations in the future. So trust me, because I know where you're headed. All right, last one. Okay, describe how the graph of g of x equals 2x minus 3 can be obtained from one of the basic graphs. Okay, so first of all, my basic graph for this one would just be f of x equals x. There's my parent, right? Just a simple line with a slope of 1 and a y-intercept of 0. So pretty unassuming. All right, we have two transformations here. We have a multiplied by 2, so that would be a vertical stretch. Vertical stretch by a factor of 2. And then we also have down 3. So vertical shift down 3. So first I'm going to take this line and I'm going to do a vertical stretch by a factor of 2. That means I am going to make the graph twice as steep. So this point was 1 away from the x-axis, now I want it to be 2 away. This point was 2 away from the x-axis, now I want it to be 4 away. So notice how that just changed the slope from 1 to a slope of 2, right? Up 2 over 1, up 2 over 1. So that changes the slope of my graph. So my graph should now have a slope of 2, which if you look at that graph, is it not in slope-intercept form, right? So it has a slope of 2, and its y-intercept should be negative 3. And now we have to move that whole thing down so we can get that intercept of negative 3. So we're going to take this whole graph, move it down 1, 2, 3, but it's still going to have a slope of 2. So it's still going to have a slope of 2. So notice this green line is going to be parallel to that red line. Oops, I kind of messed it up over there. Please don't hold it against me. So this green line here is g of x, right? It has a slope of 2 and it has a y-intercept of negative 3. And that's how you get it from these transformations. So hopefully you've learned a little bit about transformations over the course of these last 5 videos. Hopefully now that you've seen the multiple and you've done them all at once, so make sure you practice them one at a time before you start trying to put them all together at the end, because it can be confusing. So thanks for hanging in there, and please come back next time when we start talking about doing a lot of fun things with our functions, like combining them and composing them and finding inverses. So make sure you come back for that.